Hello. What I want to do is have a look at some more integration by inspection questions. What I'm going to do is take you through examples 9b, 10 and 11 from the textbook. Okay. So the first one is integral of x squared plus 5 cubed. Now the thing to realise is that you don't expand the brackets with these questions. Okay, because the power could be something like 7 or 9 or 11 or something like that. No, the thing to do is not expand the brackets, but try and consider an alternative method. And the thing you've got to remember is that integration by inspection means you should be able to, within time of course, just look at a question and write down what the answer is, or just show a tiny bit of working only and then write down what the answer is. These should not be onerous. There shouldn't be many lines of working with these. So let's just have a look to see what's going on. So what you should look at is what is going on in the brackets. So you've got x squared plus 5, and that's raised to some power. As I said, the 3 is not really the important thing. We look at what's in the brackets. Now if you differentiate what's in the brackets, you get 2x, and just notice you've got a multiple of that outside the brackets. Now that tells you, or it should tell you, that the answer you're looking for is something to do with x squared plus 5 to the power of something. So what we're going to do is just go with y equals, from home, x squared plus 5 to the power of. Now because we're integrating, we're going to increase the power by 1, so we'll go for power of 4. Now when we differentiate that, we're going to get dy dx is equal to 4x squared plus 5 cubed, and then differentiate the brackets, you get 2x, so that will become 8x x squared plus 5 cubed. And if you notice, that is very similar to what we've got in the integral. It's just the factor of 8 that is different. So that tells us that our answer is going to be 1 over 8 and then x squared plus 5 to the power of 4 and then plus c. Okay, so the thing to do is just check what's in the brackets, differentiate that, and if you've got a multiple of that outside the brackets, then you'll get some sort of idea as to what form the answer will take. Okay. Right, let's have a look at the next example. Integral of cos x squared x over 2 plus cot x cubed. Now please don't just look at one of these and think, oh my gosh, it's just so hard, so complicated, where am I going to start? Because to be honest, with that attitude, you're not going to get through the rest of the chapter. Okay. What you need to do is just pick out bits of it. Okay. With a fraction, it's a little bit easier because you can split it up into numerator and denominator. Now, with some of the previous questions we've looked at with inspection, remember the natural log questions when you had a fraction? What we looked at was the denominator, and if we differentiated the denominator, if we got some aspect of that in the numerator, then that told us what our answer is. Now, this is not a natural log question, of course, because this denominator is raised to the power of 3. Okay, so it's like saying 2 plus cot x to the power of negative 3, isn't it? But we're going to use the same technique of differentiating that expression in the brackets and seeing what we get. Now if we differentiate 2 plus cot x, we get negative cos x squared x. And isn't that absolutely lovely? You've got cos x squared x on the numerator. And it's as simple as that. That tells us that that must be the form that we're looking for. Okay, so we're going to go for y equals 2 plus cot x to the power of something. Now because we're integrating, if I increase the power by 1, it goes to the power of negative 2, doesn't it? Okay, so that's what I'm going to go for to begin with. Then we'll differentiate that and see what we get. So we'll have negative 2 plus cot x, decrease the power by 1, it's about negative 3. Differentiate what's in the brackets, we're going to multiply by negative cos x squared x. If I just write that a little bit better, the two negatives make a positive. We're going to have 2 cosec squared x and then over 2 plus cot x all cubed. And that is extremely similar to the actual question, isn't it? The only thing that's different is the factor of 2. So that tells us that our answer has got to be 1/2 of what we originally thought. Okay, so half of 2 plus cot x to the power of negative 2. And again with plus c. Is that okay? Right, let's have a look at the next example. Now I've cut this one a little bit short, okay? I appreciate in the actual textbook they include limits, but I feel that it's the integration bit that's probably you're going to get stuck on, rather than the actual limits, because you've substituted limits plenty of times by now. So I'm just focusing in what the actual integral itself is, and it's the integral of 5 tan x sec to the power of 4x dx. Okay. Now what we're going to do here. Now I could start off with a couple of things you don't look at. You don't look at the tan x. Okay. If you look at tan x, that's not really going to help you out. If you differentiate tan x, you get sec squared x, but you need sec to the 4x. Okay, so that's not going to help you. In previous examples, indeed in the last example as well, we looked at something in brackets and seeing what happens when you differentiate it. Well, just remember that this term here, the sec to the 4x, that is the same as sec x to the power of 4. So that is your bracketed expression. That's your bracketed expression. And if you just check when we differentiate sec x, we get sec x tan x. And that is where the tan x is coming from. Okay, so if we can differentiate an expression involving sec x, then we will get to something like the required result. Okay, so in our first attempt, what we're going to do is consider something to do with sec to the power of something. Okay, so sec to the power of, well, I'll tell you what, let's go with 4 to begin with. Okay, it may be right, it may not be right, but let's just try it. Okay, you might try sec to the power of 5 or sec cubed, but let's just try sec to the power of 4x. What I want to show you is what happens when you differentiate that, you see. When you differentiate that, you're going to get 4 sec cubed x, and then differentiate the sec x, you get sec x tan x. Sec x tan x, and if we simplify that, we're going to get 4 sec to the power of 4x tan x. Now if you notice, that is extremely similar to what we actually need. Okay, we just need 5 tan x sec to the power of 4x, and we've got 4 sec to the power of 4x tan x. Okay, so what that informs us is that that original assumption was very nearly correct, wasn't it? Whoops, let's not put the x there. Let's put the x down by here. So it means we must have sec to the power of 4x as our answer. Now the 5 just means that we'll need to multiply this by 5 as well, and because we were a factor of 4 out from our answer, we'll just have that as 5/4 sec to the 4x plus c. Okay. Now you can see with this one, the increase in the powers does not work, does it? Let me just show you slightly differently. Okay, why the increase in the powers does not work. I'm hoping you got it, but I'm just illustrating another example too. Suppose we start off with y equals sec to the 5x, and we want to differentiate that. Well, we're going to get 5 sec to the 4x times sec x tan x, which would be 5 sec to the 5x tan x. So can you see with these ones, the power for the sec x part just remains the same, doesn't it? And so if it's the same for differentiation, it'll be the same for integration as well. Okay, so with these ones, a little bit of practice is needed really until you're comfortable with it, but your answer is going to be something very similar. Okay, that is the power of 4 will be exactly the same. Okay, as I said, I didn't do the limits bits, but you can look at the textbook to see how that that pans out for you. It's fairly easy. Right, that's it for the time being. Hopefully you'll be hearing from me again soon. Goodbye.